All right, in this video we are going to discuss t-tests. And as you would recall from the readings from this week, there are three different types of t-tests that can be run. The first type is called the one-sample t-test. Now, as the name implies, this refers to the fact that you have data on just one specific sample. So for example, in this data set that we've used in the past of these college students, we have data from one sample and we want to compare the value for that sample on one variable to some other known value, maybe a population value. For example, maybe you work at a school, you have data from your school, a sample from your school of performance on the state reading assessment for a certain grade level, and you have data on what all of the students across the state of maybe Texas have scored on that assessment, and you can actually compare your sample from your school to the value of the population of all of the students in Texas, and you can do that through what's called the one-sample t-test to see if that differs. The second type of t-test would be a paired sample t-test. In that case, again, it's data coming from one sample, the same sample, but either at different time points. So maybe they take a pre-test, do some type of activity, intervention, something else, and then take a post-test, data on at two different time points, but for the same group of people, and or maybe it's the same group of people and you want to assess how they score under one condition versus another, or on one type of assessment versus another. That's called a paired t-test. So the data comes from the same groups of people, but either at two different time periods or from two different measures. And the last type of t-test that is talked about is an independent samples t-test. And now an independent samples t-test, there are actually two different groups. So there's some type of variable, or what we call an independent variable, that distinguishes groups. So for example, in this data set, as we're going to look at in a minute, gender would be a group, in that you have males and females. Athlete could also be a group, athletes and non-athletes. Now with a t-test, it can only be a grouping variable that has two groups. You can't do a t-test, an independent samples t-test, if you have more than two groups. So if you want to compare males and females, as we're going to look at in a second, on some variable, we can conduct an independent samples t-test. So I'm going to start by showing the one sample t-test, and I'll just use as an example, we have one sample here, again, of college students, and let's say I have some data from the population of college students to show that they generally score 100 on this reading, whatever this reading assessment is. And again, we have data from our sample on reading, English, math, and so on. But let's say we have some data that suggests that the average score across the population of college students is 100. And I want to see, does the sample of my students that I have data for, is it different than the population mean of 100? So I would go to Analyze, and I'm going to go down to Compare Means and Proportions. You can see one sample t-test. You're going to get a box that looks like this, and again, the data that I'm interested in is this reading score, so I move that over. You have to, this important box down here, yours will generally start and say 0. So if you do not change that, it's going to say 0, and it's actually going to be testing whether your sample score on reading is higher than 0, and that's not what we're looking at here. We want to know if we think the population is 100, their score is 100, we want to see how our sample scores in comparison to that. So once I do that, once I make sure I put 100 there, I hit OK, and you're going to get some output that looks like this. Again, what you're going to see here is it gives us our mean for our group of 425. You can see the mean here is 82, standard deviation and such. And then here's the results of our one sample t-test. Here's the t-value. It's negative because the fact that our mean of our sample is smaller than 100 than the value that we were testing, which is shown right here. Test value is 100. You can see the p-value, we're looking at the two-sided p in this case, and we're looking for values below 0.05. You can see that this is quite a bit below 0.05, meaning there is a significant difference. So this score of 82 for our sample is significantly different than 100. Those are the key things that you would want to report: the mean and standard deviation for our sample, the t-value, and the p-value that shows. So in this case, we can reliably say that our sample scores significantly lower than the population of 100. Let me do another quick one real quick and say, let's say this time we're interested in the math, and let's say we know that the population of college students generally score 80 on this. So I'm going to make sure I put 80 here. here because that's what we're testing it, or comparing our group's mean to that, and I'm going to hit OK. And again, you'll see, okay, look, in this case, our sample mean is 65 with a standard deviation. We only have data on 422 students for this one compared to 425. We see our t-value, and again, our p-value is quite a bit below 0.05, so we can conclude that our sample mean of these college students is significantly different from the population mean of 80. That's how you do the one sample t-test. Okay, now paired. So an example, again, paired t-test could be pre-post, could be the assessment across two different conditions. So in this case, I'm gonna test to see if this population of students scores differently between the math and the reading, and also I want to test, do they score differently between the English and the reading. So again, same sample of individuals. It's called a paired test because the data comes from two different variables but from the same group. So I'm going to still go back to my compare means. This time I'm going to do paired sample, and you're going to get a box that looks like this, and you just plug your pairs in. So I said first I want to know if the reading and the math for these students are significantly different, but here I can actually do multiple paired t-tests at the same time, so I don't have to do one at a time here. So I also said I wanted to know if the English performance was significantly different than their reading performance. And I could keep going on and on if I had multiple other pairs that I wanted to compare, but we're just going to stick with those two. So let me hit OK. And again, we'll start up here. So here's our data. So for the first analyses I did, it gives us our reading mean, our math mean, which we've already looked at. You can see 412 students. For our pair 2, there was data on both of these for 399 students. So you see our mean for English, our mean for reading, also our standard deviation. It gives us correlations. And then if we come down here, here's what we're looking at, this paired t-test. For our first analysis, which is the reading compared to math, you can see it says a mean of 16. You might wonder what that means. Well, that's just simply the difference between this reading mean and this math mean. And if we scan what we're really looking, we want to come all the way over here, and we want to see the t-value, t-statistic, and then the p-value. In this case, you can see that's below 0.05. So the interpretation is, in this case, with reading is higher, that the students in the sample, their reading performance was significantly different from their math performance. Now, if we look at the second analysis, which was looking at their difference between their English and reading performance, you can already see in their means that they're very close, and that holds out again in the results here. So we have a mean difference, which is quite small. Here's our t-value, and then you can see in this case, this value is above 0.05, meaning that it is not significant. So we retain our initial hypothesis that says that English and reading performance for this group is the same. We cannot reject it as we did with this pair up here. So that is a way to run a paired sample t-test. The final one is an independent samples t-test, and again, that's when you're comparing groups. So for our analyses, we're going to use gender as our group. So we're going to say we have males and females, and it's important to know how they're coded. In this case, we have 0 and 1. I'll show you why that's important in a minute to look at. And let's say I'm interested in comparing sleep time. Do males and females, if our hypothesis is that they have the same amount of sleep time, we can actually test that with an independent samples t-test. I also want to look at reading and math, and I'm just choosing those kind of arbitrarily for our purposes, but I'm going to look at those three variables, sleep time, math, and reading, and see if there are significant differences between males and females. So I go back to Analyze, Compare Means. Now we select Independent Samples t-test. And then you're going to get a box that looks like this. Let me reset that all. Okay. So the first thing is, which are the variables? This test variable means what's the outcome or the dependent variable you're interested in, and you can look at as many as you want. In this case, we're going to look at reading, math, and sleep time. And then this grouping variable refers to how are the groups defined. In this case, we're looking at gender. And here's where it's important. They want you to tell it which groups, because sometimes in data sets there might be there might be a 0, 1, 2, there might be a 1, 2, and 3, because maybe there's 3 groups. In an independent samples t-test, you can only compare 2, so SPSS is making you tell them what groups are you going to compare. So you have to click on this define groups, and you're going to get a box that looks like that. And if I left it like this, it's going to give me an error message because there is no 2. So we only have 0 and 1 for our male and female. So I have to put in 0 and 1. Hit continue. Now it's going to compare the group 0 versus the group 1, which is our males and females. And if I hit OK, I now have, again, we have our statistics. So here for reading, math, and sleep time, we have our means for the males versus females, males versus females, males versus females. And then you have your results for the independent sample t-test. So we have our result for the reading one, the math, and the sleep time. And I want to orient you to a couple quick things. So this first thing you see here where it says F and significant, that is what's called the Levine's test. Essentially what that is doing is testing for whether the variability, the variance, standard deviation for the two things you're comparing, are they equivalent, or are they what we call equal variances, or are they significantly different? So in this case you see standard deviation are pretty similar. Here they're pretty similar, but here in math there's quite a bit more variation in the female score versus the male, and so the SPSS makes you do a correction for that. So the first thing you need to do is look at this. If it's not significant, you can stay on this top line where it says equal variance is assumed. You have your t-value, and here's our p-value. In this case, it's not below 0.05, so we can say that here are the mean scores between the groups, and there is no significant difference for gender on the reading variable. I'm going to skip down to sleep time real quick because we have the same thing. This is not significant, so we assume that their variability is equivalent, so we stay on this line. Here's our t-value of 1.267. We keep going over here to our two-sided p, and we see again 0.206, which is above 0.05, not significant, so we would conclude that sleep time, reported means of sleep time, is not significantly different between males and females. But let's go to this math one. Okay, first we start here. Oh, and here's where we see it's below 0.05, so we cannot assume that these variances are equal. You can actually see, like I said, quite a difference here. So we just drop down to this next line where it says equal variance is not assumed, and we use that data. Here's the t-value. You notice that they're very similar. It just does a slight correction. And then in the p-value, again, it's a little bit different. It's doing, again, a bit of a correction. And here we do have 0.006, which is below 0.05, meaning that it is significantly different. So what we're saying is this mean for males of 66.55 is significantly different, in this case significantly higher, than the female score on this math assessment of 64.33. So again, reading was not statistically significant, sleep time was not statistically significant, math was statistically significant. And that's how you can run an independent samples t-test. So again, one sample t-test is when you have one sample and you want to compare to some value that you know either from the population or from the literature or something, and you're going to compare your sample to that value for a specific variable. The paired is when you have, again, the same group of people and maybe you're assessing them at two different time points or on two different measures or under two different conditions. And then lastly, when you actually want to look at the differences between two groups, in this case gender, you can run what's called an independent samples t-test.